All right, algebra 2, here we go. 5-3, solving polynomial equations. Very similar to what we've done in the past. I mentioned it in the last section, how we factor the quadratics and stuff. Similar, okay? How can you use that factoring to solve here? Well, just like we did before, set it equal to 0. And remember, when you factor, a couple things, that, and I've shown some of this already in the last section, but to kind of bring this back to you, and it's on page 311. They do a good job of showing some examples of stuff of what we've already done. Like we've already found greatest common factor. That should be the first thing you look for, and you saw that in what we did in the last section. Factoring the trinomials, we did that in the last section. If you get it to a point where you get the difference of two squares, okay, do that. Factor by grouping, we've done that. There's an example of that in the on page 311 also. And then factoring the sum or difference of two cubes, okay, and there's some good examples of that again on 311. So let's look at some examples here of factoring. And we say we're factoring, but remember, we're finding the zeros and the roots here, okay? Just like we did before, we're just kind of expanding the last section. So you get a polynomial function, 2x cubed minus 5x squared equals 3x. Set it equal to 0 by subtracting the 3x over. Now when I start to factor, when I got set equal to 0, I factor. And I notice here that I have x's in each, so I factor out my x. And then what's left over is a trinomial, x squared. So, but I got a 2 here, so I'm going to fabulous factor. Put my 2x, and my 2. 2 times a negative 3 is negative 6. Factors of 6 that when I subtract I get negative 5. And that's 6 and 1. 1 minus 6 is negative 5. So because I have a minus minus, I get a plus minus. And the 1 goes with the plus and the 6 with the minus. That's where I get here when I FOIL. And then 2 goes into both the 2 and the 6. So this is what I end up with in factored form. Set each factor equal to 0. And then solve. That's already done. Subtract the 1 and divide the 2 out. I get a negative 1/2. Add the 3 over. I get x is 3. So these are my zeros. If I was to graph this, I'm going to go through 0, 1/2, negative 1/2, and 3. Okay? But here all we got to do is factor it. I just want you to realize that we're still finding the zeros here. It's the same deal. This example here, x to the 4th minus 3x squared equals 4. I'm going to subtract my 4 over to set it equal to 0. Now what I want you to notice here is it's a trinomial, okay, and it's to an even power. If the degree is even, okay, we can split that up. Remember, x squared times x squared is x to the 4th. You just add the exponents and you get your 4. So I split up x squared and x squared. Minus minus, so I'm going to get a plus minus. Factors of 4 that differ by 3. 4 and 1, and 1 minus 4 is negative 3. So the 1 goes with the positive, the 4 goes with the minus. Okay? Just as if that was x squared instead of x to the 4th, we can treat it the same way because it's a trinomial even power. Then I set each one equal to 0. Subtract the 1, square root both sides. Remember, negative 1 is the same as I squared. We did that when we were talking about the quadratic and complex numbers. Okay? And you can take the square root of that. I get plus or minus I is for my x. These are imaginary solutions. If you're graphing, you get a relative min or max maybe there, but it won't touch the x-axis. So add your 4 over here, square root both sides, plus or minus 2. Okay? So those are going to be real roots. That's where you're going to cross the x-axis. X cubed, subtract the 1 over. I could take the cube root of both. So if you look on page 311, you've got the difference of two cubes. So if that was, your a would be x and your b would be 1, so there's your a minus b. A squared plus ab plus b squared. Okay, so it's all in there. I can set this factor equal to 0, and I get 1. But here I've got a trinomial, and there are no factors of 1 that add up to 1, so I got to use the quadratic formula. Long? Yes. Too bad. It's just the way it goes. Okay? Toughen up. So my a is 1, my b is 1, and my c is 1. Negative b plus or minus b squared minus 4ac all over 2a. And then when you work it out here, you got a minus 4 here, so I'm going to get a negative 3. I'm going to change that to a, remember, a 3i squared. So I can take the square root of the I squared. That's why it's out front here. So negative 1 plus or minus I squared root of 3 over 2 That's my other root, or my factor, okay? Not really a root, because I'm not going to cross the x-axis with an imaginary number, okay? So there's a couple of examples there of what we'll be doing in class, solving problems by factoring, okay? Take a look at 311 and look at those examples there. We've done all of that already. Hopefully that's a good refresher for you, and we'll get after this tomorrow in class. See you then, bye.